Hello class, this is a video tutorial continuing on related rates. In this video we're going to look at another example of related rates. So at any time you can pause and give this a go. Now let's get on to it. So the radius of a metallic sphere is expanding at 0.04 millimeters per second as it's being heated. What is the rate of volume increase when its radius is 3.4 millimeters? Okay, so this one's a little bit more difficult, and hopefully you can see how we're going to get there. Now, here's a very methodical way of arriving to the correct answer. So ultimately, we are looking for the rate of volume increase. In this context, a rate is often something against time. So if we want the rate of the volume increase against time, this is our goal. Okay, so we're looking for this. So this is we'll call this our goal. Okay, we're looking for dV on dt. So the change in volume against time. But what do we have? What are we given? Well, we are given the radius of a metallic sphere. So the radius is it's expanding at 0.4 millimeters per second. So think about this. The change in the radius against time is equal to 0.04 millimeters per second. Think about that. The radius of a metallic sphere is expanding at 0.04 millimeters per second. So the rate of, the change in the radius against time is this value here. What else are we given here? Well, if you consider what else we have, it is a metallic sphere, and we're looking for the volume. So we actually have the equation for the volume of a sphere. That's going to be volume equals 4/3 pi r cubed. Okay. Now look very carefully. dV on dt is what we want. We have dr on dt. Okay, if we can somehow cancel dr, so we need to multiply this by something on dr. Well, if you look very carefully, you could have found dV on dr. So once we have this, we can substitute it here. From there, we can cancel dr, leaving us with dV on dt, which is what we need. Let's take a look. So let's find dV on dr. Differentiating this with respect to r. So it's going to be 12 on 3 pi r squared, which simplifies to 4 pi r squared. So now we have dr dt and dV on dr. So we can now find dV on dt equaling dr on dt is 0.04 times dV on dr, which is what we just differentiated here, so times 4 pi r squared. I'm just going to grab my calculator. That's going to be 0.04 times 4. That's going to be 0.16 pi r squared. So the rates of change of the volume over time is 0.16 pi r squared. So we've now found an expression for dv on dt. We now need to know what is the actual rate when the radius is 3.4. Well, that's not too hard. That's r equals 3.4. And we're going to substitute that into our expression here. Let's just clean this up a little bit. I'm going to substitute it into here. So this is going to be 0.16 pi times 3.4 squared. So again, just using my calculator, 0.16 times 3.4 squared. That's going to be 1.8496 pi. And let's just keep that in decimal form to the nearest 2 decimal, which is approximately 5.81. Since this is in millimeters, it's going to be in millimeters cubed because this is the volume we are calculating. And that concludes this example here. So I hope that wasn't too difficult, but I hope you can see how setting out what we need and what we are given, we can find what we are exactly looking for. I'll see you in the next video where we do another example where it gets slightly more difficult as well. Hope to see you then. Best of luck.